Well, we are very interested in learning about the surface velocity field in the ocean, because when there's an oil spill, much of the oil is at the surface of the ocean, and in fact in the upper few inches of the ocean. And this seems to be an area that was not well investigated in oceanography, because oceanography is traditionally coming from submarine warfare. Submarine warfare is deep ocean. So even though it's the first place you see when you look at the ocean, the surface of the ocean, we don't know what's going on there. It's also at the interface between the atmosphere and the ocean, okay? And it's a moving interface. So the atmosphere is 100 times faster than the ocean, and it's 1,000 times lighter than the ocean. So there's a huge change over almost like a millimeter, it's a discontinuity there, and that's where most of the oil is. And since the interface is moving, the waves, you cannot put any instruments there. It's not very easy to put instruments there. So this is a challenging problem, yet it's the most important problem. If you want to predict where the oil is going, you need to know the exact surface velocity in the ocean. So that's what we have been trying to do. When there's an oil spill, the first order problems are where is the oil going, okay, and how much oil is going. It's not enough for you to, let's say, one day find the oil, because there'll be disruptions during the cleanup, during the night and during the stormy times, and you need a prediction capability and understanding of what's going to happen to the oil the next day. And what we are finding out is actually the conditions in the ocean change very, very rapidly. And also, like in the case of the Deepwater Horizon, when the oil spill is very, very big, even though you have a huge amount of assets, let's say ships, you need to be able to allocate them in the most optimal fashion. Okay? In other words, you need to go where most of the oil is, or you need to go where it's most dangerous or most pressing in terms of landfall. And those are the questions that require knowledge about ocean currents. CARTHE initially started as a modeling group. We were very, computer-oriented. But over the course of this GOMRI research, very generous funding by GOMRI, it was like a Red Bull injected into the observing systems, we found incredible things in the ocean. So the observational capability actually increased. So because of that, even though we started as a modeling group, we became now almost entirely an observational group. We still have one more experiment. We have conducted a very, very large experiment 1 year ago, where we had 3 planes and 2 ships, and we released more than 1,000 drifters in the ocean. We released more than 8,000 plates, and these were observed through the planes and the satellite. We were also running our real-time models. So this was the whole idea was to bring a lot of observation systems looking at the same patch of the ocean. And now we have another experiment, coastal experiment. And during this experiment, we are going to again try even more different techniques. And then we will be at a situation where, with all these tons of data, there needs to be some thinking. After years of development and planning and execution, this is when things will get, I think, very quiet. We'll go back to our offices and write papers and analyze and spend a lot of time with our students and postdocs and talking to one another. I don't think there'll be a lot of seagoing, but because you don't want to go back to the ocean without really extracting everything from these data sets. It's almost a waste. You want to get the most out of it, and then when you really get the new questions and get the answers, get the questions, and then when you really run out of it, then you have to go with the next level. So this is what I see. We are going to execute another experiment, and then we are going to work very hard to write the papers and provide the latest knowledge about the state of the Gulf.